Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 11 students and the topic of discussion is probability. This is an introductory video on this topic. Now question comes, what is probability? It is a mathematical measure of how likely an event is to occur. We can also call probability as chance of an event to occur, and it is expressed as a number between 0 and 1. You may be wondering why we need to study probability. For example, if weatherman says there is a 40% chance of rain tomorrow, you may or may not end up getting wet. Whether you need to take umbrella with you or not, this probability number can decide. Or for example, when your favorite sports team plays a game, you don't know whether they will win or not, or you would like to know what is the probability of winning the game. Let us try to understand probability with some basic definitions, like what is an experiment. Any happening for which the result is uncertain is called an experiment. The possible results of an experiment are outcomes. The set of all possible outcomes of an experiment is the sample space. We'll understand all this with some examples. Let us first define those terms. The sample space is denoted with the symbol S, and the size of the sample space, that is total number of possible outcomes, is denoted by N of S. Similarly, an event is a specific set of outcomes of an experiment that you are interested in. An event is denoted with the letter E, and the number of outcomes in the event is N of E. Let us have some examples of sample space. Find the sample space for each of the following. One coin is tossed, two coins are tossed, three coins are tossed. Let us see what happens when one coin is tossed. When one coin is tossed, the option or the coin can land up either head or tail. So the sample space is given by S equal to H comma T. These are the events, H, heads, and tail as T. Let us take this next example. Now two coins are tossed, so it could be head head, or it could be head tail, or it could be tail head or tail tail. So this is the sample space when we toss two coins. Similarly, when we are tossing three coins, the sample space is given by this. What is probability of an event? The probability of an event is given by P of E equal to N of E by N of S. P of E is the probability of event E, and NE is the total number of outcomes of event, and N is the total number of outcomes in the sample space. Let us take few examples and try to compute probability. In the first problem, two coins are tossed. What is the probability that both lands heads up? So let us first write the sample space. Sample space is given by HH, HT, TH, TT. This is head and tail. So both coins can be head. One can be head, another can be tail. Then first can be tail, second can be head. Both can be tail. So this is the all possible outcomes here, but we are interested in both being heads. So this is the event HH. What is the probability of occurring? This is occurring only one time. 1 over total outcomes in sample space is 4. 1, 2, 3, 4. So probability of event E getting both heads up is 1 over 4. Now in the second problem, a card is drawn from a standard deck of cards. What is the probability that it is an ace? In a deck of cards, there are 52 cards and 4 aces. So probability of drawing the ace is 4 by 52, which is 1 over 13. So let us understand what is event A or B. Union of two sets A and B denoted by A union B contains all those elements which are either in A or in B or in both. Let us take one example. A is 235, B is 135. What is A union B or A or B? All the common elements plus the balance elements. The common elements are 3, 5. What are the other balance elements? 1, 2. So A union B or A or B will be 1, 2, 3, 5. What is event A and B? Intersection of two sets A intersection B is the set of those elements which are common to both A and B, which belongs to both A and B. So let us take same example. A is 235, B is 135. What are the common elements? 3 and 5. 3 and 5, we write this as A intersection B or A and B. Another event could be A but not B. We know that A minus B is the set of all those elements which are in A but not in B. Therefore, the set A but not B may be denoted by, let A equal to 235, B equal to 135. All those elements of A which are not in B. Only two elements. This is not in B. All those elements of A but not in B. So A has 2, 3, 5. 3, 5 is in B. So we don't have to include those and only 2 will remain. That is A minus B. What are simple and compound events? If an event has only one sample point of a sample space, it is called simple event. For a sample space, for tossing two coins at a time, head, 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 tail, tail, head, these are the possible outcomes. So each of these is a sample event, simple event, each of this. So E1 is HH, E2 is HT. So E1, E2, E3, 4 are all simple events. Now what is a compound event? If an event has more than one sample point, it is a compound event. For example, if we take 3 toss of a coin and we want to find exactly one head, so these are the possible outcomes and this is more than one event. So this 3 together will constitute a compound event because the sample point is more than one. What is mutually exclusive events? This is very important. Two events A and B are called mutually exclusive events if the occurrence of any one of them excludes the occurrence of the other event. That is, they cannot occur simultaneously. It means A intersection B is phi. So A and B are mutually exclusive because A intersection B is phi. Let us try to understand the axiomatic approach to probability. Let S be the sample space of a random experiment. The probability P is a real valued function whose domain is the power set S and range is the interval 0, 1. Probability is always between 0 and 1 and it cannot be negative, satisfying the following actions for any event. P of E is greater than or equal to 0. It can be 0 but it cannot be less than 0. Probability of a sure event is 1. If E and F are mutually exclusive events, then P of E union F is P of E plus P of F. Let us try to understand this with the Venn diagram. This contains set A and this is containing B. The common element is A intersection B given by this white color. This is A minus B, this blue color, and this is B minus A this side. Now what is P? A union B is P of A plus P of B minus P of A intersection B. Full of P of A is this, P of B is this. 2 times we have included this space, so we subtract that. So P of A union B is given by this. Now question is, if A and B are mutually exclusive, then A intersection B is phi. So this P of phi is 0. So P of A union B equal to P of A plus P of B for mutually exclusive events. Friends, with this we conclude this video. Please like and subscribe my channel so that in future videos can be released to you instantaneously. Thank you very much, friends.